Now I'd like to talk to you about the telescope. Here I have a diagram for an astronomical telescope in which we have a converging lens for the objective lens and another converging lens for the eyepiece. I've shown the object some distance away. This object might be the moon, or it might be a planet, or it might be even a terrestrial object such as a tree or something. But whatever object we're looking at, we have an object showing the orientation, and the object we assume is very far away compared to the distances involved in the telescope. Very far away compared to the focal length of either of these lenses, for example. I've shown the focal length of the objective lens. This first lens is called the objective lens. Second lens is called the eyepiece. And for a typical telescope, we want to have the focal length of the objective lens greater than the focal length of the eyepiece. Here, the objective lens, the focal length is f1. The eyepiece focal length is f2. And it turns out that the magnification of a telescope depends on the ratio of the focal length of the objective to the focal length of the eyepiece. The optics of the telescope go something like this. Here's the object. The objective lens forms an image, a real image at this point right here, just beyond the focal point of the objective lens. And then the eyepiece looks at that, or the eye, whatever instrument is looking through the telescope, looks through this eyepiece at this image as if it were an object. That forms a secondary image here that the eye actually sees. This secondary image, when it forms a final image on the retina of the eye, that image on the retina of the eye is going to be larger than it would be if the eye looked at the original object directly. And the ratio of the size of those two images, the one looking through the telescope and the one without the telescope, is called the magnification. In many telescopes, the magnification can be 50 times or 100 times or even greater. The greater the smaller the focal length of the eyepiece, the greater will be the magnification of a telescope. So you can change the magnification of a given telescope by keeping the same objective lens, but by inserting different eyepieces, of course, just one at a time. Short focal length eyepiece will give a large magnification. Longer focal length eyepiece, magnification will be less. Now, I'd like to demonstrate how that telescope works with a couple of lenses here. I'm going to actually build a little telescope right here in our laboratory. This lens here has a focal length of about 14 inches, and I'm going to use that to serve as the objective lens. So that will be the lens corresponding to the objective lens in the diagram here. The eyepiece has a shorter focal length, and this will serve as the eyepiece. So if I'm going to look at particular objects, such as maybe this ball over here, we can think of that as maybe the planet Mars we're looking at, or any object at some distance. So I let the light from that object come up to the objective lens, pass through the objective lens, and form an inverted image just beyond the focal point. Then I take that inverted image and take the eyepiece and use it as a magnifying glass, and I look at that inverted image, and that forms another image that the eye actually sees. So the objective lens forms the first image. The purpose of the objective lens is to take that object that's many miles away and bring it up close so that I can look at it with the eyepiece as a magnifying glass. And when I do that, I put my eye just beyond the eyepiece here, and I line things up properly, and now I can see that image through the telescope, and my eye sees that ball as if it were about twice as big as it appears without the telescope. To show you that, I'd like to bring the camera down here and have the camera look through this telescope in much the same way I'm looking through it with my eye. Now that we have the camera in place, I'm going to line the telescope up so the camera can see through it. And we're going to see what the camera sees looking through the telescope, and then I'll remove the telescope and let the camera look at the ball directly, and we'll notice that the camera sees the ball as if it were larger when it looks through the telescope, and when the telescope is removed, it'll see the ball in its natural size. When I hold that up with my eye, I see the ball about twice as large looking through the telescope as I do when I look at the ball directly, showing the magnification of the telescope. Now, there are other kinds of telescopes. There are reflecting telescopes, etc., In fact, binoculars and microscopes and other telescope-like instruments work on the same basic principles.